Hello, everybody. Thanks for joining me for today. We're going to start into Chapter 2, Section 7. Now, this is the same chapter that we've been working in, but it is a new section. And in this section, we're going to talk about a couple things. The first and most important thing is what an inverse function is and how to find them. So, basically, in a nutshell, inverse functions undo other functions. So, that's a pretty important thing to be able to accomplish, depending on what type of problem you're working on. So I'm going to show you some basic things about how to find an inverse or how to verify that two functions may or may not be inverses. So let's get started. First of all, we know that a set of ordered pairs can represent a function. For instance, f of x equals x plus 4 from the set a equals 1, 2, 3, 4 to the set B equals 5, 6, 7, 8. So what they're showing is if you take these four numbers right here and you plug each of those in for X, these are the outputs that you get. So these are your domains, and then these would be your range numbers. Now it says in this case, by interchanging the first and the second coordinates of each of these pairs, you can form an inverse function of f, which is denoted by f inverse. So that word right there, you see that new notation that we've not seen. That is not pronounced f to the negative 1. That denotes f inverse, and that is how that is pronounced. So what they're saying is we need a way to be able to take the numbers that are over here and put them back into their original form. So we can take them from the domain and put them into the range, but then if I want to take those and put them back into their regular form, we need a way to be able to do that. Well, for this particular function, it's pretty easy to understand how we would do that. If you look at our function f takes inputs and it adds 4 to them. And that's how we got these new numbers. Well, if I wanted to undo that, I would simply take these four numbers and subtract 4 from them. So each of those numbers, if we subtracted 4, would put us right back to the original set of numbers that we started with. So what you see that I have written here, this f of inverse of x, let me erase this so it's a little easier for you to see. But this x minus 4, f inverse of x minus 4, this function undoes this function up here. And so these can get much more complicated. This is a pretty easy one because the first function that we started with just adds 4. So the inverse of that is going to be to subtract 4. Now, another important thing to understand about what a function and its inverse, how they operate together, is if you compose them together, meaning you take one of the functions and put it into the other function, you will end up with the identity function. And that identity function is simply x. All right, so if you look right here, I have this first composition. I have f of f inverse of x, which means I'm going to take my first function, f of x, which is x plus 4. My second function, f inverse, is x minus 4. I'm going to take this and I'm going to plug this right into there for this first composition. When I do that, what you can see is the 4's end up canceling and I'm left with x. Now, if two functions are inverses of one another, then you should be able to compose them both ways. So you should be able to do f of f inverse like we did here, and you should be able to do f inverse of f like they're doing in the second line, and both of the outcomes will be x. If you notice, you got an x for both of those. So it doesn't matter how you compose them. You actually, whenever you're proving two things are inverses, need to compose them both ways. But if you compose them both ways and you get x both ways after you compose them, then you can say for certain that these two functions are inverses of one another. So there's a couple ways to find inverses. The first and most basic way is to do it intuitively, which is what I did for that last problem. We had a function that added 4 to all of the inputs. So the inverse of adding 4 would be to subtract 4. So we wrote the inverse function. So looking at this next one, I have a new function, f of x. This particular function, f of x equals 4x, multiplies each of the inputs by 4. So then you have to think, well, how do I undo multiplication by 4? And the way that you would do that is you would divide everything by 4. So when I go to write the inverse, I write f inverse of x equals x divided by 4. Now, the next thing to do is to verify that these two are indeed inverses of one another. And again, these are easy ones. These do get harder, and there's actually another algebraic way to find inverses that I will show you eventually. But first, we need to compose these. So we have f of f inverse of x, and that is 4x, but in place of x, I'm going to put the inverse on the inside, just like you see here. And what you'll see is the 4's eventually cancel, and we're just left with the identity function, x. That's good. Now you do have to show it the other way. So we need to do f inverse of f of x. So f inverse is the outer function, that is x divided by 4. F of x is going to go on the inside. So the f of x function is 4x. So I'm going to put that right there. You can see once again the 4's cancel, and I'm just left with an x. So there you go. Both of those functions, when we composed them, gave us the identity function, which means they are inverses of one another. Here's another example. So this says find the inverse of the following function, then verify they are inverses of one another. So this particular one is f of x equals 1/5 x. So I'm taking and I'm multiplying by 1/5. Now, if you remember, the way that we undo multiplication is with division. So we would need to divide this by 1/5, but we don't ever divide fractions. We keep the first fraction, change the division to multiplication, and then we flip the second fraction. So instead of dividing by 1/5, we would actually multiply by 5. So this function inverse, f inverse of x, is going to be 5x. Essentially, this function right here divides everything that you would input it by 5. So now that we have the inverse, we would compose both of those. So f of f inverse of x is equal to 1/5 x, but then the f inverse goes there. 1/5 and 5 is 1. It cancels, and we're just left with x. We are going to compose them the other way. You do need to compose them both ways. So we're going to find f inverse of f of x. So f inverse is the outer function. F of x is the inner function. And you can see we have 5 times 1/5, which is 1. These both cancel. And once again, we're left with x. So we verified both of these are inverses by composing them. And when we composed them, we got the identity function in both compositions. All right, so that's what I have for you today, guys. As always, if you have any questions, feel free to email me. Have a great day.